Hello everyone. We're now going to go over classes in C++, which will be a little easier than classes were in Java the first time because you've already had so much experience and the concept is very similar. There are just some syntactic differences that I'm going to point out. And there's a couple things with static and dynamic memory, so dynamic allocations of classes that I'll have to point out. But let's just dive right into it. So how about I go ahead and make a person class, just like I had done before. Now one strange thing you notice right off the bat is this actually needs a semicolon. Okay. And it doesn't need a public or a private designator there. So here's the next weird thing. So you can have public and private, but they have to be in their own blocks. So here's my private block. I started by typing private colon. And so we'll say that the person has an age, and maybe they have a class here or something. Or maybe, well, let's give them a name instead. Okay. And then I have public, same thing. That's going to be its own block here. Everything in this block of code is going to be public. So I can have a constructor int a char. So let's, just for the moment, I will use different names for the parameters than here because there's something a little weird that I have to introduce first. But okay, so I could say then in the constructor age equals a and name equals n. Okay, so I'm going to copy over the pointer to a string, some kind of string for the name. I'm going to copy over the int for the age to those private variables. Let me also make a void function called printinfo. So we don't really have a toString in C++. It's a little more complicated than it is in Java, so I'm not going to do that for now. Instead, I'm just going to make a void function that prints out some stuff. So person name is this, age is this. Okay, so I'll just say name, age there. And that's my class. Okay, so person has an age and a name. I can have a constructor like this, and then I'll print info. Maybe I can also make a method like celebrate birthday. So void celebrate birthday. And then I'll say age plus plus. So this is kind of similar to stuff I'd had in Java before. Okay, so the only differences really are that all the public stuff is in one block together. All the private stuff is in one block together. And I can have a method here too. So I could have a private method. Let's call it void do private stuff. Who knows what that is? And maybe here is where I have the magical ability to set the age to 0. Okay. So let's now instantiate an object of type person and see what that looks like. So what I can say is person p. And so this is a little interesting. This is going to be a static object. So if I say person p and then in parentheses the stuff I want to put to the constructor, so I'll say 31 and then Chris. So this is a string literal. Actually, let me be safe and say const char name equals Chris, and then I'll pass on, I'll cast that as just a char. Okay. So anyway, this is going to call a constructor. Now this syntax looks a little different. I didn't have the new in there. Okay, so this is something called a static object. Now let me just compile this code. Oh yeah, and then I'll say, just to show you that this actually worked, I'll say p.printinfo. Okay. So let me go ahead and compile this. So I'm at the root of Sigwin right now. This file is in the module 9 folder. If I type ls, I see that there's the module 9 folder. So it's in my home directory, at the root of my home directory. So I'll say cd module 9. And I'm in there. And there I am. Okay, so I made a file called class.cpp. I'll say g++ out class.cpp. And when I run class, it prints person name is Chris, age is 31. Cool. Okay, so that worked. So I created a string literal, passed on the string pointer to the string literal and my age, and that stuff got copied over to private variables here. If I try to say something like printf I p.age. That's not going to work because age is private, right? Same thing if I say p.do private stuff, that's not going to work either, because it says it's private. Okay. Also, it shouldn't be in a print statement because it's a void. It doesn't return anything. Okay. Anyway, so that's public and private, so they work just fine. Now, the thing I want to show you, though, is it's also possibly to dynamically allocate an object. Let's say that you didn't necessarily know what these things were going to be at runtime, or even how many people you had. So you can say the following, and this is going to look a little more like Java. But instead of this is a static object instantiation. I can make a dynamic version of the object like this. Person pointer p is equal to new person 31 char name. Okay. The thing I have to do, though, is, so this is going to dynamically allocate a person. I then have to remember to delete it. Okay, so anytime I see a new, I have to have a delete. So even for objects that are dynamic, I have to delete them. Okay. This is actually not going to work here. Watch, I'll show you. It's not going to compile. It's going to say request from member print info in P, which is a pointer type person. Okay, so I actually have to do something a little bit different now to access methods and variables in a dynamic object. This is a pointer, so I have to actually dereference the pointer before I can call a method. So this will work now. Okay, so here's my dynamic object. And I just have to remember to actually go to the object in memory before I print info, because this is just a pointer. P is a pointer here. Okay. So now it compiles just fine, and it works. Okay. So static object, you just declare it like this, and the constructor goes right there after the variable name. Dynamic object, it's really a reference. You get back a reference to this chunk of memory that's been defined, that's been allocated for the object. And then you use the new syntax here. So this part looks a lot more like Java. But you have to remember before you call it any instance methods of this class, you have to remember to dereference the pointer. Okay. This actually becomes a little bit cumbersome to type, so there's a shorthand for this in C++, which they hinted at here. They said maybe you meant to use this arrow. Okay, so the shorthand for this is actually p arrow print info. So whenever you see the arrow, what you remember is this is dereferencing p and is going to the actual object in memory. And now you can, after the arrow, you can call things on the object. So just to show you this still works, there it is. Okay, so that's another way to write the same thing, which is it's shorthand. It's, it's just an arrow instead of having to write these parentheses, and it's kind of annoying. Okay. All right, so that's static objects and dynamic objects. Now that I've shown you this notation, I can actually explain how to have the same names of the parameters up here. So if I just try to say this, it's not going to work. I mean, these statements are a little weird anyway. Age equals age, what does that mean? I'm setting a variable to be itself. Okay, so this didn't work. Okay, it said person name is blank, age is 869. Boy, I don't know if I'd want to live that long. Okay, so what I have to do actually is there's this, which is a pointer to this object, which means that I have to actually use the arrow notation. Okay, so this is a pointer to the object that we're talking about here. So actually, I'll do it both ways. I'll say, okay, I can dereference this and then write dot, or I can say this arrow name. So let me just show you that this compiles. And now we're back in business. Okay. So that's how you have to deal with this for an object in C++. This is actually a pointer to the object. Okay, so you can have, I mean, I could also, even if I had a static object, I could still create a pointer to that object, and I would have to use the same notation. So if I said something like this, person p pointer is equal to the address of this static object, I would then still have to use the arrow notation on p pointer. Okay, so whenever you have a pointer to an object, you have to use the arrow notation, because you have to dereference the pointer first and go to the object in memory, then call the thing. So I just want to show you that real quick. Oh, and of course, if I have a static object, I don't need to delete it anymore. Okay, it's automatically cleaned up for us. Okay, so that was a lot of stuff.